So let it e equal to 0, or let it be e equal to 0.5. Inelastic collision will take it, and it's moving with a velocity u. What conditions will come here? Yes, in fact, collision will occur. So during collision, what conditions will arise? Let's take a situation of like this. Now, the particle will collide here. Everything lies on smooth horizontal surface. Almost all the problems. Now, this is the collision will occur and impulse will act. That impulse will also act on the square plate. So what will happen to the ball after collision? Let's assume that it is having a velocity v1. That of the square plate will have velocity v2. So how do you can say it will move towards right? I think apply impulse momentum equation J. So it will acquire an impulse J will act on the square plate. So it will acquire momentum 2mv2. Then at the same time, the impulse J, what it does, it will set up angular impulse, no? J into L by 2 clockwise, where on the plate. So therefore, now it's having a tendency also to rotate. It's not like just initial angular momentum. You must also look what the impulse acting. How that impulse acting on the rigid body will set up angular impulse, and how that angular impulse is acting, that will determine how in what direction it will rotate. Sir, why only it will rotate about O? There's the next question. There's the next question where students supposed to ask. Why it will rotate about O? Why not about any other point? Square plate is what? Rigid body. If a rigid body is set free to rotate, will rotate about its center of mass, and O is its center of mass. Finish all. No, not a big deal here. What we should do now? What all I can write? Can I apply conservation of linear momentum? Yes, it is mu net impulse is 0 along x-axis. So initial momentum mu, final momentum mv1 to mv2. So therefore u equal to v1 plus 2v2. So there's a one equation. And then what is the next again? Quotient of restitution formula, or say conservation of angle. About what point it is conserved? About any point on the square plate or about any point on the ground. But we will consider about a point about which the system is rotating. Moreover, particle is not get stuck to the plate. If it gets stuck to the plate, then we should consider angular momentum about center of mass of system. Since particle will not get stuck to the plate, so therefore the plate will rotate about O. So angular momentum will consider about O. So then LOZI equal to, so this will be mu L by 2 mu L by 2 initial angular momentum. So I'll put also directions you see. Then m1v L by 2 that of particle. Finally IO omega 2. What is IO? Moment of inertia of the plate. How much IO is equal to? What is the value of IO? What is IO is equal to? So let me substitute all, and this should be clockwise. So mu L by 2 mv1 L by 2 plus 2m L square by 6 omega 2. Since all are in same direction, okay, no problem that is. How many unknowns are there? Again, same thing, v1, v2 and omega 2. So I need one more equation. So this, if you eliminate m and l and also 2, so this u equal to v1 plus 2l omega 2 by 3. Equation 2, this equation. I need one more. What is one more? Quotient of restitution formula. What is the velocity of this? Velocity of point A. along line of impact, it should be measured. No? So what is the line of impact? That's horizontal line is a line of impact. So anything directed towards right, I'll take it positive. So E is equal to, this will be really very good problem. What is the quotient of restitution? What is the velocity of point A along line of impact? There are two velocities are there, no, for the plate. Check carefully. So this is the V2 and also angular velocity omega. Because of that, it will have V2 and also tangential velocity. Call this is R omega 2. And this angle will be theta. It will be 45 degrees. So what is the velocity of point A along x-axis? V2 plus R omega 2 cos theta. Theta we know it's 45 degrees. R is L by root 2. What is the velocity of point A along line of impact has to be considered here. Velocity of particle, no, anyway, it's along line of impact here. So what is this? I think this dotted line is what? Line of impact. Okay, let's write the equation for quotient of restitution. E is equal to velocity of particle along line of impact minus that of the velocity of the point A along line of impact minus velocity of the particle divided by initial velocity of particle, and initial the plate is at rest, that will be 0. So E is equal to how much? 0.5. So this should be V2 plus R omega 2 cos theta minus V1 by U. What is theta? 45 degrees. What is R? L by root 2. Again solving equation 1, 2, 3, we'll get the required answer. There's a generalized method. Not only rod, we can bring any other object. There's a firm idea is what a student must have. So what is this square plate lying on smooth or gentle surface? Able to analyze this? See, there's no end. I'm telling this one that this topic is again like infinite topic, like rolling. I can keep on bring things. So what are the things which will help you? Conservation of linear term, conservation of angular term, quotient of restitution. If elastic collision equal to 1, that's all. If particle gets stuck to the plate, what you're going to do? You're not going to show that V2 and omega 2 about center of mass of system. The center of mass of system is somewhere here. About that point, the particle plus plate will rotate. It'll come somewhere here. About that point, you consider everything, angular momentum, everything. Able to get this? These are very important. Elastic, perfect inelastic means particle gets stuck. Then what happens? This V2 you should not show about some center of mass of system. Then omega 2 about center of mass of system. Then what are unknown things? I'll give one. So like it'll be easy for you. It'll go and collide. This is O, mass is 2m, side length L. Then after collision, what do we expect? It'll get stuck to it. When it gets stuck to it, what do you expect? Center of mass. So center of mass, what happened? Should be somewhere here. Will agree? Center of mass must be near to the heavier mass. So there's a center of mass. So everything you have to show about, just show this much here. About center of mass, the system will rotate. Then what you should do? Calculate this y. Calculate that y. So center of mass of system will be somewhere here. No? So m u Y is equal to IC omega. What is IC? Moment of inertia of the plate plus the particle. Then after getting this much, then how to calculate that V? Applying condition of free momentum. Mu should be equal to m plus 2m into V. It will rotate about center of mass. The plate plus come particle. Rod particle. A rod and plate. You have to be careful. Different shape rigid body comes. Little bit complications will come. So what are the complications? Like if you take the instead of square plate, no, let me bring a circular disc. You see, no, m1. It is moving with a velocity u. This is o. It is having a mass m2 and radius r. Let's have a general discussion. Whatever the type of rigid body, let's see that what conditions will arise here. It is at a height h. So definitely what will happen? So this distance, if you write r by 4 or r by 2, it will come and strike at this particular point. So this is a disk. What will happen here? Let me put E equal to E between 0 and 1. In advance, only rod and particle they ask. I'm just making a guess. Maybe they may ask like this. Let's be ready, no? Why to confine ourselves to only one set of problems? Because disk also rigid body. Okay, now, so let's not waste any time. Sir, there's a disk has come, suddenly curved shape, anything. Let it be. What best we can do it, we'll analyze here. So it will be like this, and the particle will come and get stuck to it. So we know only one thing, like the impulse will act here. How do that impulse will act here? Impulse will act along common normal. Already we have exclusively discussed in collision. Can you remember? The concept of collisions is what you have to bring into picture. This is the overall condition. Proceed like this. And we have some mathematics. So we know this is r, this is r by 2. So we can bring this theta. No, because of this impulse acting, what will happen to the disk? How do it will move? Really, I should leave such questions to students. Then only you'll become good engineer. But nowadays, the things are like everyone wants gifted. They want knowledge without any stress, without any putting any effort much. No, what will happen to this? Will rotate or not rotate? It will not rotate. No, why it will rotate? Look at this impulse. It is passing through its center, no, and this what happen? It is free to rotate about to, and this impulse what's happening? It is acting. How it is acting? It will the point of application of impulse what will pass through the axis of rotation. So this is as good as like a the force intersects axis of rotation. So what is the torque due to impulse will be zero. The disk will not rotate. So it becomes simple one problem of what? Collision problem. Nothing to do. Sir, after collision, how do the disk all that one will move? Now, what do you expect the disk after collision? How it should move? It will just move along the direction of impulse. No, clear this. It will just move in the direction of impulse. Nothing. What about the particle? Okay, now resolve the velocity. This velocity will resolve one in this direction, other in direction. So the tangential velocity. So the velocity which is along common tangent will not change. No? So after collision, the particular this will have two velocities. One V1 parallel, V1 perpendicular. Let me call this as V2 perpendicular. And this is the line of impact. I'll bring it. Just high school geometry, nothing big. There's just high school geometry, common normal, common tangent. That only we are applying, not anything very big. That's all. So no angle level of for the disk. This is what you have to remember. So don't think that's a rotation mechanics. This problem is in rotation. It should rotate because the name of chapter rotation mechanics. Name of chapter rotation mechanics. Why rigid body will rotate? Should not happen. No. So some students are thinking like this. Huh? I think you should be more realistic. Based on name of chapter, concept will not come. Okay, this so you have to be very extra alert with such thing. Means in all such numericals, the rigid body will rotate after impulse. No, you have to look at the rigid body. If it is free to rotate, it rotate about center of mass and look at that impulse. Is it passing through axis of rotation? That's all. Finish. I think it's a pure collision problem. No. So now, how to what is V1 parallel? I think you go back. We have done so many problems. Take help of collision. Nothing to do with this particular thing. Can we calculate all this V1 parallel, V2 parallel? We have nothing to do with our rigid body mechanics. In exams, students, I don't know what will happen to you. You start thinking rotation mechanics. It's a collision problem. So how do I come to know? That's what when you do different types of sir, why don't you apply things like this here? Here, the after collision, the square plate is having a tendency to rotate. So therefore, I'm entering into angular momentum. I'll okay. No, just one more, few more ideas are there. When you go for Olympiads, no, this is what happens for Olympiad. Olympiad is not something big. Olympiad is all about like